All right, so starting today, lesson 1-8, scientific notation. If we go back to yesterday's was word problems with greatest common factor and least common multiple. So if we hit the kickoff here, Neil has two pieces of wire, on one 18-foot long and the other 12-foot long. He wants to cut them up to produce as many pieces of wire that he can that are all of the same length, with no wire left over. What is the greatest length in feet that he can make them? Well, again, look for that keyword greatest. That means greatest common factor. You know, you think greatest, big, largest. That's all greatest common factor. Least common multiple. You'll see like smallest. What's the minimum? What's the least amount he can do? That whole thing. So, greatest common factor, 12 and 18. 12 would go 2 and 6. 6 would go to 2 and 3. 18 would go to 2 and 9, which goes to 3 and 3. So, greatest common factor, we're looking for what do they have in common? Well, we have a set of 2's, and we have a set of 3's. Oh. So 2 times 3 would be 6, and that's our greatest common factor, and that's in feet. Now, other way to do this, remember, is listing them out. So 12 would be 1 and 12, 2 and 6, 3 and 4. 18 would be 1 and 18, 2 and 9, 3 and 6. So it's the biggest one. Well, they both have a 6. Two ways we can do greatest common factor. So getting into scientific notation. So scientific notation, a lot of times you'll see this in your science classes, hence the scientific notation. Is we're going to write it where it's a number that is greater than 1 but less than 10, so a single digit decimal times 10 raised to a power. So that power 10 exponent there. So we're going to start by writing all the non-zero numbers, and then any zeros that fit in there as placeholders, we need to keep those. But really we're going to look at the non-zero numbers and then place the decimal after the first digit. We're going to count how many times the digit moved, and then that's our exponent for the power 10. Now, if we're dealing with a number that's bigger than 1, we're going to have a positive exponent. If it's a number between 0 and 1, so if it's less than 1, then we're going to write it as a negative exponent. So if it's a smaller number, negative exponent, bigger number, positive exponent. And that's really why they're using it, is if we get to dealing with really big numbers or really small numbers, they're rewriting it so that it's workable and easier to write. So if we do some examples. So if we write 546 in scientific notation. So here, all of them are non-zero numbers. So we're going to write them all down. So 5, 4, 6. Then we're going to come here to the left side. We're going to go past the first non-zero, and we're going to put our decimal. Then write times 10, and now we need to find our power. So normally on whole numbers, the decimal is going to be on the very right side. If you don't see a decimal, assume it's on the right side. That's where it is. So we're going to have it right here between the 5 and the 4. So we need to move around the 6 and around the 4. So we're going to move it twice. So we put 2 as the exponent, and we were bigger than 1, so it stays positive. So that's right in scientific notation to go backwards, and it's supposed to be 9.61 times 10 to the negative third. I don't know why that didn't copy. Sorry about that. So to write it out, again, we're going to start with those non-zero numbers. So 961. So if the decimal is right here, we're going to move it 3 times. That negative means we're going to make that number smaller, so we need to move the decimal to the left. So 1, 2, 3 times. So we need to add 2 zeros, and that's where the new decimal is. And then we'll put our decimal on the outside here. So our number we'll need is 0.00961. Okay? So that's our final answer. This is what we're looking for here. So the next one also didn't write. And so this one here is 8.2 times 10 to the 5th. slide this up. So start with your 8.2. So we're going to move it 5 times. It's positive, which means we're going to make it a bigger number, a number larger than 1. So we're going to move the decimal to the right. So once, twice, 3, 4, 5 times. So we're going to move the decimal. So we're going to fill in 1, 2, 3, 4 zeros. So our number we're going to have is 820,000. And that's our number. So back to scientific notation. So here we're dealing with a smaller number. So again, we're going to start with the non-zero numbers. So don't have to worry about this one, don't have to worry about this one, don't have to worry about this one. But then we have 6, 8, 5. So 6, 8, and 5. After the first digit, we put our decimal times 10 raised to a power. So if the new decimal is right there, that means we moved it once, twice, 3 times to get it there. So we put it to the third power. We're less than 1 here, so that makes it negative. We had a smaller number, and we're writing it in scientific notation. So negative for the exponent then. So bigger number here, so we're going to write all of the non-zero numbers. So we would write our 6, 9, 8, 2, 3. So all those non-zeros. Now, if there would have been a 0 between, say, the 9 and the 8, we would have kept that 0 there. But these zeros on the end, we're going to drop. So come here to the left side, go around the first number, put the decimal, times 10. And so if our decimal is right here, we would move it 1, 2, 3, 4, 5, 6 times. So we put to the 6th power. It was a number bigger than 1, so it stays positive. Now, but one example I want to show. So like this one here, say it was 72405. 1, 2, 3, 4, 5, 6, why not? So big number here. We would still write down 72405 because again, this zero's in between, and that's kind of what I talked about there. But the zero's in between these non-zeros, so it has to stay. All these other ones, though, we're going to drop. All these on the end, we don't worry about. We're still going to come over here and do 1 time around. Again, we want this to be a single digit, so 1 to 9 should be in here. No zeros, no 10, 20, 100. No numbers bigger than just single digit from 1 to 9. Times 10. So we go, decimal is going to be right here. We start here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be to the 10th, and it was bigger, so it stays positive. So that's scientific notation. Let me know if you have any questions on it, but that is the lesson.